Okay, welcome back. This is going to be another example video, so I'm going to be going over a question from exercises 5.4. This will be number 5. It's 5. Which one should we do? Let's do 5D. So 5D asks us to determine whether or not a set is inconsistent using the rules of SD+. So to check whether or not a set is inconsistent, what we do is we take all the members of the set and we turn them into our premises. So the set, if you look at 5D, I'm not going to write it out here because it'll take a little bit too long, but you'll notice that there are 4 sentences, and I'm just going to turn them right away into the form that we need them to be in. So the first sentence is a conjunction. So this is B and H or Z. The second sentence is not Z, then K. Our third sentence is B if and only if Z, and that is the antecedent of our conditional not Z. And then we have not K. So each of these sentences is a member of the set, and we're going to determine whether or not we're going to derive a contradiction. And by deriving a contradiction, we're going to show that this set of sentences, so the set that contains each of these sentences, is inconsistent. So what we need to do is find a contradiction somewhere. And the first thing we'll do is just have a look at what our premises are saying and get a feel for why it is that they should be contradictory. And a good place to start here is just with our atomic sentence, not K, and try to reason backwards a little bit about the consequences that not K has in terms of the other sentences. So we notice that K is the consequent of this sentence here. And since we have the negation of the consequent, then you know that the antecedent has to be false as well. In other words, you would have not Z. And if we had not Z, then we notice that that would be the negation of the sentence here, right? Because we'd have an extra not out in front. So we'd have not Z. So that's the negation of this consequent, which would require us to have the negation of this antecedent. So if we had not B if and only if Z, what that means is the truth value of B will differ from Z, right? If we have not B if and only if Z, that means that one of them will be true and one of them will be false. So we want to keep that in mind. So we can't ever have both B and Z be the case if this sentence is true. And then we look, well, we notice up here we have B as the conjunction of this sentence. So we know B is going to be true, right? Because in one step, actually, maybe we'll write this down just to keep this in mind, is we have already B here by conjunction elimination. And this will be from line 1. So if this sentence turns out to be true, then not Z would have to be the case. And the way we've done the derivations so far, when we had the when we did this sort of backwards chain of consequences of not K, at some point we had not Z, which means not Z, right? We could use, for example, so if we had at some point not Z, we could use double negation to just get Z. And that conflicts, right? So having B and Z conflicts with this fact that we sort of also thought about along the way. So we see that there's going to be some kind of contradiction, and a good candidate then might be between the connection between B if and only if Z and this sentence right here. Alternatively, we can also see if we could just get Z and not Z. So for now, we might not, have perfectly clear in mind which sentences are going to be contradictory or not. But it's at least good to sort of think about this a little bit beforehand and maybe start following out some of these consequences, and then it'll become clear later on about which sentences might turn out to be contradictory. So it's okay to move forward a little bit blindly at first, as long as you have some idea of where to start, which we've just done here. So let's follow through a little bit with not k here. So we have not k, and we have k as the consequent here. We know by modus tollens this gives us not z. So this will be by modus tollens on line 2 and 4. Okay, and we can use double negation to give ourselves just z. So this will be by double negation from line number 6. Okay. Now also you'll notice that not z here, right? Well, actually, using 6, so not z. That's the negation of this consequent, which means we'd have to have the negation of that antecedent as we just had. So we would have not be if and only if z. And that will be using line 3 and line 6, again using modus tollens. And now you might think, okay, wait, so I get the idea, right? We've got B and we've got Z, and both of those we've derived, so if one of them is true, so if the premises are true, then these will have to be true as well, which means they'll have to have the same truth values. But this sentence is saying, no, look, they actually have different truth values. So we don't yet have a contradiction here, right? We need some sentence of the form, some sentence P, and then we also need the negation of that sentence. But this will be relatively easy now, right? We can just quickly construct this biconditional using Z and B. So how do we do that? Well, we use the usual strategy we have had before, where you start out assuming B, you get Z, then in a separate derivation here, maybe that wasn't as clear, but you get the idea, this is a break here. In the second derivation, subderivation, you assume Z, and you get B, and then you can introduce B, if and only if Z, right? To get biconditional introduction, citing these two subderivations. And with Z, I just need to use reiteration here, and I just need to use reiteration here for B. So this will have been from 7, and this will have been from line 5, and this will be lines 9 and 10, 9 through 10, and 11 through 12. Biconditional introduction. And this completes our derivation for the contradiction that we needed, right? This sentence contradicts with this sentence right here. And so now we've shown that this set of sentences is in fact a contradiction. Okay, so I think that gives you, those are 3 solid examples that we've done now from the problem set. These aren't directly from the problem set, but these are problems related to the problem set. So hopefully these give you a good sort of head start on how to do some of these problems using the different rules that we've been exposed to.